Welcome. So in this lesson, we're going to be going through exact values of circular functions. To help us through all this theory here, we're going to be referring to a presentation here, and hopefully this allows us to visualize what's going on. Okay, so we've seen the unit circle before. We know that we're dealing with an angle of theta here, and you can also see that this point here has these coordinates. My x value is my cos, my y value is my sine, and you can see that here as well. This is my y value, which is sine. This is my x value, which is cos. What we're going to be filling out is this table here, which is in your notes, and it's actually pre-filled for you, and that means you can just pay your utmost attention to this right here. I have 100% of your attention right here. We're going to be filling out these with the exact values. And exact values correspond to different angles. So 0, pi on 6, pi on 4, pi on 3, and pi on 2. So there are exact values which correspond to each of these angles. We've actually seen the exact values for the angle 0 and pi on 2 in previous lessons. In this lesson, we're really going to be concentrating on pi on 6, pi on 4, and pi on 3. We're going to be introducing these. So we're going to be finding the exact values for sine, cos, and tan. So sine is my y value, cos is my x value, and then tan is sine over cos. So we're going to be finding all of these exact values. Let's just remind ourselves how exactly this works again. So as I change my theta value, my sine and cos changes, and as you can see there, that's obvious because the coordinate changes here. So as you can see, it changes. Okay, so let's begin, and let's begin by looking at the exact values which correspond to an angle 0. It looks like this. So as you can see here, I have the coordinate 1, 0. So my cos is 1, which is quite clear here, and my sine is 0, which also you can quite clearly see that the sine is going to be 0 here. So that means I put a 1 here, I put a 0 here, and then my tan is going to be 0 divided by 1, which is just 0. So we put a 0 there just to denote the tan. The next angle we have to concern ourselves with is pi on 6, which is 30 degrees. So let's now get that angle up. So this is the angle pi on 6 here. And as you can see now, our sine is a half and our cos is the square root of 3 on 2. So it's going to have these coordinates right here. If we were to divide these coordinates, we would end up with 1 over the square root of 3. So that's going to be our tan value. Let's now move on to our next angle, which is going to be pi on 4, which is 45 degrees. So as you can see here, I'm changing my theta value. And this one is going to have a sine value of 1 over the square root of 2, and it's going to have a cos value of 1 over the square root of 2. So this is very nice. They're the same. And that means we can write it like this. And if they're the same and we divide them by each other, that means it's going to be 1, because if I divide a number by itself, it's just going to be 1. And that's why our tan is going to be 1. Next, pi on 3, which is 60 degrees. So let's change this again. And as you can see, now I have pi on 3. The y length, or the sine length now, is the square root of 3 on 2, and the cos length, or the x length, is a half. So we're going to give it these coordinates, and if we were to divide this, so a half divided by the square root of 3 on 2, what we're going to end up with is the square root of 3, and that's going to be our tan value. And then last, the one that we have seen before, which is pi on 2, which is 90 degrees, is going to be right here. And as you can see this time, I'm going to have a sine which is 1. My cos is going to be 0, and if I was to go 1 divided by 0, it's going to be undefined. So our tan here is undefined. So we have just covered the exact values for the first quadrant, but obviously each of our quadrants have their own exact values. Now what we're going to learn very soon is that it's really useful if you can commit to memory the exact values for the first quadrant, because then the rest of the exact values can just be found using our symmetry properties. I'll be showing you different techniques on how to memorize these. But my favorite technique is just brute memorization. You just sit down one day and you just try to remember the first quadrant. So this is what it looks like. So here's what we just found then, our first quadrant. And as you can see, we have exact values for every other quadrant as well. What you'll notice is that they're all pretty much the same, except that the negatives change. So some of them are negative, some of them are positive. So then the sign in front of them changes as I go from different quadrants. And obviously the angles here all have something in common. They're going to be symmetrical, as we soon learn. But yes, if you just memorize the first quadrant, everything else will make sense, because then we can use the symmetry properties that we learned in previous lessons to help us figure out which ones are positive and which ones are negative. But as you can see here I have negative the square root of 3 on 2.5, Over here, I have the square root of 3 on 2.5 as well. So the only difference is that half, that negative. The only difference is that negative. These ones are the same. The only difference is negative. These are the same. The only difference is the negative here. And then this is going to be the same as this one. The only difference is that both of these are negative, and it goes on. So as you can see here, we can use these symmetry properties to help us figure out the exact values of the other quadrants. What's really necessary is you just memorizing the first quadrant once. Okay, so with all that being said now, let's go back to our notes. So as you can see here, you've already got that table filled out for you. And over here, you also have the first quadrant. So you've got the first quadrant here. And I just think it's really useful for you to commit this to memory. I think that's the best way to go about it, just committing it to memory. I will be showing an alternative very soon, but all right, so the diagram above shows the exact values for the angles in the first quadrant. All other quadrants can be found by symmetry. Perfect. Now, another way of doing this, instead of just brute memorizing the first quadrant, is to use special triangles. So let's now go through what those special triangles are. So there are two special triangles. One special triangle helps us get the exact values for pi on 6 and pi on 3, and the other special triangle helps us get the exact values for pi on 4. Let's begin by going through this one right here, and I just want you to follow along at first. Don't write anything down because I'm going to rub things out. I'll tell you when to write things down. So this is an equilateral triangle. Each length is 2. If it's equilateral, we can also say something about the angles. Remember, a triangle adds up to 180 degrees, and if it's equilateral, all the angles are going to be equal. So that means they're all going to be 60 degrees, and we want to write that in radians, so we're going to say it's pi on 3. This is going to be pi on 3, and then let me just zoom out here. This is also going to be pi on 3. You might also want to just make a note to yourself, pi on 3 is 60 degrees, just in case you're curious. All right, now what I'm going to do now is I'm going to cut this in half. So let me just get rid of this for the time being. I'm going to cut this triangle in half. If I cut it in half, this now is going to have a length of 1 here, a length of 1 here. And if I've cut that angle exactly in half, remember it was originally pi on 3, but now this is going to be pi on 6, and that's 30 degrees. So we just halved 60 degrees, which is 30 degrees, or another way of saying it, we halved pi on 3, and half of pi on 3 is pi on 6. All right, we're now just going to rub out this, and now we just need to figure out the length of this right here. If we use Pythagoras here, if we know this is 2 and this is 1, after we do the whole big Pythagoras thing, we find out that this is going to be the square root of 3. Okay, so that is what I want you to copy into your notes, this triangle right here. This is going to be really important, and this is what you should commit to memory. Okay, let's now go through how we actually use it now. So how do we use this special triangle? All right, so if I want to find sine of pi on 6, so I'm trying to find the sine of pi on 6. So I come up here and say, well, here is pi on 6. If I want to find sine is, let me just grab this, sine is opposite over hypotenuse. The opposite of this is going to be this, and my hypotenuse is over here. So this means it's going to be a half. And that is my exact value. If I want to find cos of pi on 6, cos is adjacent over hypotenuse. So I come up here, adjacent to this is over here, and my hypotenuse is this. So it's going to be the square root of 3 on 2. And then finally, we have tan of pi on 6, which is going to be opposite over adjacent, which is going to be the square root, 1 over the square root of 3. Opposite over adjacent, 1 over the square root of 3. Okay, let's now go through the next one. So now go through pi on 3. So if we're given pi on 3 and we need to find the exact values. Okay, so for the first one, sine of pi on 3 is opposite over hypotenuse. So this time I'm actually going to get rid of this one, and that one. So now this is going to be my opposite. This is going to be my hypotenuse. My opposite is going to be the square root of 3, and my hypotenuse is going to be 2. Then for the next one, so this is going to be adjacent over hypotenuse because it's cos, so katoa. This is going to be A, so adjacent is going to be 1 on 2. And then lastly, tan is going to be opposite over adjacent. So my opposite here is going to be the square root of 3. and my adjacent is going to be 1, so it's going to be square root of 3 over 1, which is just the square root of 3. Perfect. So that's how we can find the exact values for pi on 6 and pi on 3. So as you can see, we used this triangle to get our exact values for these two angles. If you want the exact values for pi on 4, you have to use this one right here. Let's go through how we're going to write this one up. What you're going to say is that this length is 1, this length is 1, and then by Pythagoras, we know this is going to be the square root of 2. This is also a right angle triangle, and this is going to be pi on 4 here, which is, as we know, 45 degrees. Then, using this, we can write in what our exact values are. So we could say sine of pi on 4 is going to be opposite over hypotenuse. So I'm looking at this one right here. Opposite is here, hypotenuse is here, 1 over the square root of 2. 1 over the square root of 2. Next, I'm going to be dealing with cos, which is going to be adjacent over hypotenuse, which is going to be a here. So opposite adjacent is going to be there. So it's going to be 1 over the square root of 2 again. And then lastly, it's going to be tan. So it's going to be opposite over adjacent, which is just going to be 1 on 1, which is 1. Perfect. So what have we covered in this lesson? We have covered what all these values mean. We've looked at how they apply to our unit circle, so how we can visualize it using the unit circle, and also how we can use these special triangles to help us commit to memory all these exact values. In part 2 of this lesson, I'm going to be going through some questions which hopefully you will find very helpful in answering your exercise. So I will see you then.